Hey, happy Tuesday. We're making a video today about graphs of motion with and without numbers. And I wanted to just reinforce for you that graphing is an important skill that we use in this class because we're trying to relate two things, an independent and a dependent variable. We're trying to see is there a relationship, and graphing lets us see that relationship. In a lot of ways, graphing helps us kind of see the story of what unfolded. And so when I do these graphs of motion without numbers, I'm going to kind of match it up to a story. And then I feel like if you can understand that, then once I add the numbers, it'll be real easy, right? So I'm going to do two kinds of graphs here. There's going to be a distance time graph, which sometimes we'll call a position time graph. It keeps track of where you are as time goes by. And then there'll be a velocity time graph, which keeps track of how fast you're going and the direction. In a lot of ninth grade classes, they'll just do a speed time graph instead of velocity. Speed is the same thing as velocity, except for speed doesn't care about direction. So speed's pretty much always positive. Here today, we're going to be using velocity time graphs. We will care about direction, and so we will have some negative velocities. Okay, so I'm going to make the axis for these graphs, and I don't have to put numbers on them because I'm telling you this story without numbers, just to give you the idea. And then we'll do the story again, but we'll do it with numbers so that you can see how to actually calculate the real numbers to use. Okay, so here's the story. It's not much of a story. You're going to walk to the mailbox kind of slowly. You will pause for a little bit at the mailbox and grab your mail. Then for segment 3, you're going to run back to your house pretty fast. Then the instant you get back to your house, you're going to realize you dropped something. So you're going to turn around and go back to the mailbox, and you're going to accelerate as you go. You're picking up speed as you go. And then when you get pretty close to the mailbox, you're going to slow down to a stop again. Okay, so there's going to be 5 segments. Actually, we'll call them A, B, C, D, and E. And they're going to be real recognizable on our graph. So let's look at how we graph this. So I'm going to the mailbox. Okay, there's several reasons why I've drawn that starting red line like that. One is I wanted to make it constant because I'm walking at a constant speed. I wanted to make the slope constant because remember the slope is the speed. So I made it constant. Second, I didn't want it to be too steep because I'm not covering that much distance in a given amount of time. I'm going slowly. So I made it kind of not steep. Right, then we're going to pause. Okay, so that was segment A. Segment B is the pause. Right, you should recognize that as a pause because there's no change in my position. There's no change in my distance. Then I'm going to sprint back all the way to where I started. So I sprint back to the origin line, and I'm really steep there. And it's also negative because I have a negative velocity. I'm going backwards. Okay, then I'm going to turn around, and I'm going to accelerate back towards the mailbox. And the way that you look for that on this kind of graph is something that's getting steeper, right? If I were to check out a certain amount of run and then the rise that goes with it, I'm getting more rise for my run, right? So it's getting steeper. If I look at this curve, not quite calibrated there, I'm getting steeper. That would be a non-constant speed. So the slope isn't constant. And then I need to slow down to a stop, so it needs to get flatter. Right? So it's kind of looking like the letter S. All right, so we're going to label those segments C, D, and E. Right now, let's make them over on our velocity time graph. Looks like my V got a little ways away from the axis. All right, there's my velocity time graph. So now I'm going to keep track of just what is my velocity doing. All right, so first of all, my velocity is constant and it's not that big. All right, that's segment A. So whatever velocity I'm at, let's say it's 2 meters per second, I stay at that. Right, then I have a velocity of 0. That's segment B. Then I have a pretty large negative velocity. Notice I made it negative because I'm going backwards. Right? And then we'll just say I instantly turn around. So I'm going to go back up to positive territory, and I'm going to gain velocity for segment D, and then for segment E, I need to lose all that velocity so I can stop at the mailbox, right? Really confusing part of this is actually in segment D and E, we're going forward. Most people would look at that segment E and they would say, oh, you're going backwards. But we're not. We're going forward, right? This is velocity. That downhill line just indicates my velocity is going down. Can your velocity go down when you go forward? Yeah, every time you slow down, every time you stop on the brakes, you're going to be losing velocity. So in E, we're still going forward, just losing velocity. Okay, that's the whole story. Now, I bet you would like to do this with numbers. So you'll do the same story with numbers. Okay, today's assignment's without numbers, tomorrow's with numbers. So we got our distance time graph. We don't need any negatives there because we didn't get anywhere in the negative distance. And let's say that it's 20 meters to the mailbox, right? So I'm going to number by fives. So 5, 10, 15, 20. Numbers just let us tell the story a lot more precisely. Okay, then I'm going to number this by 5 seconds. So let's say 5, 10, 15, 20, 25. We actually might need a little more time than that. 30, 35 seconds. All right, so let's say to get to the mailbox, we go at 2 meters per second. That means that it's going to take us 10 seconds to go the 20 meters. 2 meters per second is going to take us 10 seconds to go the 20 meters. Hopefully you can kind of figure that out in your head. That, for 10 seconds, if every second we walk 2 meters, by 10 seconds we will have walked 20 meters. Right, then we're going to pause there, and let's just say it's a 5-second pause because we're pretty quick about grabbing the mail. Right? Then let's say we run all the way back at 4 meters per second. So in other words, it just takes us 5 seconds to come back. Right, so we run all the way back at 4 meters per second. Right, then we're going to pick up speed on the way back to the mailbox. So let's say that we pick up speed for 10 seconds, and it takes us 15 meters doing that. And then we slow down for the last 5 seconds and the last 5 meters, which is pretty realistic for running to a mailbox. And make these a little bit more uniform looking. There we go. Clean up my graph. All right, so that's the story with numbers. All right, now when I make the corresponding velocity time graph, I have to be much more precise because I actually have numbers. So one of the great things about switching the axis from a distance time graph to a velocity time graph is it's the same event, so the time axis is not going to change. So if I had 35 seconds before, I'm going to still have 35 seconds to work with. So I'm going to be like 5, 10, 15, 20, 25, 30, 35. All right, then I'm going to try to figure out what to number the velocity axis by. This is much tougher. I need to kind of look at my slopes over here and see what these were. So this was a slope of 2. Right, up 20 over 10. This is a slope of -4. So my velocity axis needs to be able to go up to at least +2 and down to at least -4. So we could say 1, 2, 3, 4, -1, -2, -3, -4. All right. I'm kind of worried that this little camera thing is going to get in the way, so I'm going to just see if I can put that right there for you. All right, so let's go with green. Okay, I'm going to do 10 seconds at 2 meters per second. All right, remember that was a horizontal line. That doesn't look that horizontal. It's supposed to be. Perfect. Kind of. Still very downhill. I don't know what's going on here. Maybe my equilibrium's off today. Yes. Okay, now we got 5 seconds at 0 velocity, so I make sure that's exactly at 0. Then we go down to -4 for the next 5 seconds, then back up to 0. Then we're going to speed up, and we're going to speed up to some speed that we don't really know what it is, but it looks like it's even steep, about as steep as 4. So we'll say we'll speed up to 4 in the next 10 seconds. And then we are going to slow down to a stop. Right, so this segment right here, we just know we're speeding up. Right, we don't really know how fast we got going, but when I'm looking at the steepness, I'm saying this is even steeper than that. So I went with 4, but you won't really have to know how to do that part for curved lines, but at least you can see the speed is increasing and the speed is decreasing. Here, when we have these constant speeds or constant velocities, we can actually get the exact right number. Okay, so this will kind of help you with graphing motion with and without numbers, understanding the story of what's going on. So you can even work ahead on that worksheet if you want to, but for today, graph some motion without numbers. Good luck.